Okay, I want to say a little bit about hyperbolas. The truth is, I minimize the study of hyperbolas. We got a lot of stuff to talk about, and but I want to say something. So this is a hyperbola. It looks a lot like an ellipse. Remember, the hyperbola is when they're different signs. So he's positive and he's negative, makes it a hyperbola. But you kind of approach it like an ellipse. Check this out. So the center is 0, 0. My h and k are 0, 0. From the center, I go over in the x direction, 6 and negative 6. And those are my vertices, like it would be with an ellipse. I go up 5 and down 5. And then instead of drawing the ellipse, I do this. I draw this little rectangle. And the only reason I really draw the rectangle is because it helps me draw these asymptotes. And a hyperbola has these asymptotes that go through the center of the hyperbola, and it goes through the corners of that rectangle, and we have an asymptote there. By the way, we often are looking for the equation of that asymptote. What is that? That's a line that goes up 5 and over 6, 5, 6x. Here's the other asymptote that comes through this corner. I guess that's y equals negative 5, 6x. And then the hyperbola starts at the vertices again. Instead of being an ellipse, I feel like it's an ellipse that's exploded or imploded or exploded. So it exploded out, and so here it leaves the vertice and it heads out toward this asymptote. Again, sort of what you might call a parabolic shape, but it doesn't follow the geometry of a parabola. It's not a parabola. It's a hyperbola shape, hyperbolic shape, as it heads toward these asymptotes. I guess a parabola doesn't head toward asymptotes. But anyway, yeah. Oh, and then it does it over here. So that's a hyperbola. The focus lives out here. There is a different relationship. Boy, I don't have that one memorized. That distance C is now longer than A and B. I believe that the relationship now is that A squared plus B squared is C squared. I think C is the longer one, the distance out here to the focus. But that's okay. I'm not gonna work with these hyperbolas much. I want to say one other thing, though. I want to say, remember all these conic sections I said this the other day, they came from this general second degree equation, ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0, a general second degree equation. We might have A or C be 0, or D or E be 0, or some of these things are 0. What I did say was that B is 0. Otherwise, when B is not 0, we get a rotated conic section that's been rotated, like an ellipse that's been rotated 45 degrees, or parabola that's been rotated, or a hyperbola that's been rotated. So here's what I wanted to say. I'm getting rid of this. I wanted to say that this famous equation is one of these, where A is 0, C is, everybody's 0, but B is not 0. So what this is a rotated conic section. Now, we don't usually think of it like this. We solve for y, and we look at y equals 1 over x. We've looked at that quite a bit in our Chapter 9 discussions and so forth. This is kind of an important graph that approaches an asymptote there. There's the x-axis, approaches an asymptote there on the y-axis. It also lives over here. It goes through this point 1, 1, and negative 1, negative 1. But guess what that is? It's a hyperbola that's been rotated. The asymptotes are here. The box is here. It's been rotated 45 degrees. Well, the box is here. And And these are the vertices of the hyperbola. It's a rotated hyperbola, rotated 45 degrees. So that's what he is. That's what he is. All right. Better do some homework. Bunch of conic section homework. I might move on into parametric equations next video.